Greetings once more, dear viewer. In the last part, we saw how the go-to map hijacked by FLATTARDS is not concordant with reality when considering simple geometry. And we wondered why people flying from Sydney to Johannesburg arrive on time, without seeing unexpected sights, and without crashing thousands of kilometres off course in the Himalayas. Unsurprisingly, a flood of choleric skid marks who think there's a global conspiracy to hide Earth's shape proceeded to smear themselves over the comment section, and in well over 14,000 comments as I speak, not one of them has demonstrated any ability to either address the content of the video or to answer even the simplest geometric questions about their disk world. Having seen their abysmal failure to wrap their minds around 2 dimensions, in this part we're going to look skyward and see if things get any better for them. Let's start with the stars. FLATTARDS love Polaris. Most seem to think it is directly on the North Celestial Pole, which it isn't, that it doesn't move, which it does, and that the sky rotates around it, which it doesn't really. However, they think it fits their space pizza idea really nicely. For those who think the flat Earth goes on forever as an infinite plane, the night sky must also be some kind of roughly planar object rotating above Earth, which it would do because reasons. Hey! For those who think they live under the dome of a giant snow globe crafted by an elusive space wizard, the night sky must be constrained by the dome in some way, which also places limits on the distance to the stars. A dome-based night sky also rotates because reasons. Hey! Unfortunately for both varieties of FLATTARD, to test these ideas all they needed was a collection of observers at different latitudes. The double star Sad-el-Melik, or Alpha Aquarius, is pretty much bang on the celestial equator, and so for basic naked eye observations is a good marker for it, just as Polaris is for the North Celestial Pole. These must be the case on the flat Earth too, so Sad-el-Melik will be flying around in a circle above the flat Earth's equator due to some unknown force. And Polaris will circle 40 arc-minutes from their North Pole due to some unknown force. Time for the FLATTARD to get his chums at different latitudes. What would they see? This rather depends on how far away the stars are. Unfortunately for us, the track record of FLATTARD astronomy is not just piss poor, but non-existent, and they haven't figured that out yet. So what can we say about Sad-el-Melik and Polaris in the FLATTARD fantasy world? Observers at the centre of the pancake Earth and those on its equator would be able to see both stars, as would every observer in between, and every observer south of the equator. However, reality disagrees. Consider the September equinox when Sad-el-Melik will be visible at night. An observer at the North Pole isn't going to see much because at the equinox the sky is still too bright, so let's head further south. Someone 80 degrees north will see the celestial pole 10 degrees from his local zenith and Sad-el-Melik 10 degrees above his horizon. Someone 70 degrees north will see the celestial pole 20 degrees from his local zenith and Sad-el-Melik 20 degrees above his horizon. Unsurprisingly then, an observer on the equator will see the celestial pole on his north horizon and Sad-el-Melik directly overhead. Why? Simple. For an observer at a given latitude, their night sky obviously consists of the 180 degrees that they can see from horizon to horizon, with their zenith directly overhead. Polaris is 434 light-years away, so is way off the top of the screen. Sad-el-Melik is about 523 light-years away, so is way off the left of the screen. The angle of elevation of the celestial equator when crossing the observer's meridian is the same as the angle between his zenith and the celestial pole, 90 degrees minus his latitude. It's all exactly what you'd expect from observers sitting on a spheroidal planet rather than a giant disk made by an invisible cosmic mage. What does this pattern of observations look like on the FLATTARD disk world? Well, we know that Sad-el-Melik is overhead at the equator, and that Polaris is overhead at the North Pole. So far, so good. But we also know that wherever you observe from in reality, that they have an angular separation of 90 degrees. Let's put an observer every 10 degrees of latitude and add in their lines of sight to Polaris and Sad-el-Melik. Where the lines of sight intersect, the vertical lines of equatorial and polar observers should provide a triangulation of the height of these stars. Unfortunately, what we find is that to match observations, each star would have to be situated at different heights at the same time, including ground level. This not only sheds some light onto why flat-earth astronomy has neither explained nor achieved anything ever, but also presents an unresolvable paradox that leads us inexorably to the conclusion that the notion of Earth being flat is not only geometrically impossible, but also complete bollocks. Observers north of the equator looking north will, depending on their latitude, see stars that never set and that circle the celestial pole. Determining how much of the sky is circumpolar is easy, it's given by your latitude. An observer at 63 degrees north in Trondheim will see the celestial pole 63 degrees above his horizon, and so any stars with a declination above 27 degrees will be circumpolar. Simple. But what about the southern hemisphere? What will observers in Australia, southern Africa, and southern South America see when they look south? Well, according to the Flat Earth, observers in these lands are going to be looking in completely different directions, and they're sat below a sky that rotates above them around a single point. And yet, in reality, these observers will find themselves looking at the south celestial pole, and like its northern counterpart, its altitude in degrees above the horizon corresponds with the observer's latitude. Unlike its northern counterpart, the stars will appear to rotate clockwise around the pole instead of anti-clockwise. This is simply because the observer is looking at the same east to west apparent motion in the opposite direction. Flat-earth observers will, like the rest of us, be looking at the constellations of Octans, Hydrus, Mensa, Chameleon and Apus. The only difference in what will be seen by two observers in the southern hemisphere looking south at exactly the same time will be rotational. One observer's view will be a rotated view of what the other sees, and the angular difference will perfectly match their difference in longitude. It's exactly the same as happens in the north, and exactly what you'd expect of observers looking outward from the surface of a spheroid, as is the convergence of lines of longitude to a southern pole in the sky. How, though, can observers on a flat Earth looking south see the same thing when looking in different directions from a flat surface beneath a single spinning sky? They can't. It's geometrically impossible, and that's why flat-earths have to avoid the topic like the plague. One flat-earth in the comments to part 1 attempted to excuse this by claiming that the South Celestial Pole isn't a real pole, whatever the fuck that means, and that it moves. Unfortunately, what this laughable ad hoc excuse fails to consider is that you can sit and watch the southern sky all night rotating around the South Celestial Pole, and the pole doesn't budge one bit. It also doesn't account for how two observers looking south at the same time in different lands can see the same things with only a rotational difference. Had flat-earths bothered to travel a few thousand kilometers and look at the sky, they could have reached a simple conclusion for themselves. Both their ad hoc excuses and their disk world are bollocks. When the stars are out of sight and out of mind in daylight, things don't get any better for flatwits. Having a universe rotate around their space biscuit like a flat-earth version of geocentrism would present the obvious problem of the whole surface changing between night and day at the same time. Clearly, this doesn't happen, as it's always daytime for half its area and night for half its area. This perplexed flat-earths, and they devoted their finest minds to solving this problem.
Blah, 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 blah. Finished!
What they came up with, in the form of yet another ill-considered ad hoc brain fart, was this. In their fantasy universe, the sun flies around above the Earth in a circle every day. Whilst the rest of the world laughed, flat-earths smugly thought they had this science business in the bag. They were then informed of the obvious problem with this idea, namely that if the sun is above a flat Earth all the time, it would be daylight all the time, and the sun would be visible 24 hours a day from every location on Earth. This perplexed flat-earths, and they devoted their finest minds to solving this problem. Rather than admit their stupidity, they doubled down. What they came up with was this. The sun behaving like a spotlight. This happens because of reasons. Here we have the flat-hard sun flying around above the Earth. It's an equinox. At each of the 2 equinoxes per year, the sun skims the horizon at the poles and is directly overhead the equator. On the flat Earth, the same must apply, so the sun is directly above their equator, and night and day are of nearly equal length. So what flat-hards are trying to say is that a single light source flying around 3,000 miles above Earth somehow illuminates half of the world. And the shape of the illuminated area has to change every day as the seasons drift. But let's come back to that another time. We're already getting a whiff, more of a stench, that flat-hards can't tell night from day any more than they can tell their arse from their elbow. So what do the transitions between night and day look like at the equinoxes on a giant space pizza? An observer on the equator will still see the sun pass directly overhead at solar noon, so the sun must be over the equator. This means observers on the flat Earth have to observe the sun rising directly northeast. It would appear to rise from a more northerly direction the further south you go, and tend towards a more easterly direction the further north you go, but would never rise in the east. Similarly, when the sun sets, an observer on the equator of the flat Earth would see it set directly northwest, setting on a more northerly heading the further south you go, and a more westerly heading the further north you go. It would never set due west. You'll be unsurprised to hear that reality disagrees. What actually happens at the equinoxes is that all observers at all latitudes see the sun rise due east and set due west, geographically speaking, not magnetically. Flat-hards have 3 choices at this point. They can accept reality and that their idea simply doesn't work, or they can deny reality and continue living in their little fantasy, or they can detail a mechanism by which equatorial observers see the sun a full 45 degrees off where it would actually be in their world, and that explains why any such mechanism would cause a deviation elsewhere that is a function of the observer's latitude, despite Earth's atmosphere being a homogeneous mix of gases that has no idea where it is. They will of course go for option 2. Having done this, we can expect them to adopt the other flat-hard stalwart, make up an ad hoc answer, and pretend that that explains everything with no further investigation being necessary, because reasons. A favourite excuse for things in the sky not being where they should be is refraction. In this case, that would not only demonstrate that flat-hards don't know what refraction actually is, but that they expect refraction to be affected by the observer's latitude rather than by any fundamental properties of Earth's atmosphere. For everyone to see the sun rise in the east on a flat Earth, we re-encounter a familiar problem. The sun would have to be in multiple places at the same time for observers up and down the world. And of course, people on the other side of the world will be watching the sun set and will face the same damned problem. All of this whilst the equatorial flat-hard in the hat says the sun is directly overhead. Since the sun isn't and never can be in multiple places at the same time, the presence of another simple and utterly irreconcilable paradox leads us to the only sensible conclusion, that the notion of us living on a giant frisbee is bollocks. Azimuthal discrepancies in the sun's position aren't the only problem facing the flying flat-hard spotlight, though. Flat-hards set their finest astronomers to the task of determining how far away the sun is. Naturally, doing anything resembling hard work was too much trouble, and since they don't have any astronomers, they were left with only one option: to pull a number out of their jacksies. The number they come up with is about 3,000 miles. However, their error margin is rather high, as some say it is up to 5,000 miles away. Well, let's stick with 3,000 miles or 4,800 kilometers. As we've seen, an equatorial observer at solar noon on an equinox will see the sun directly overhead. The distance from each pole to the equator is a few kilometers over 10,000, so let's just go with 10,000. A margin of a fraction of a percent is still better than any flat-hard has managed. When we divide that distance by 90, corresponding to each degree of latitude, we can calculate the altitude angle of the flat-hard flying spotlight above the horizon for an observer at each position as the inverse tangent of 4,800 over d, where d is the distance in kilometers from the equator. When we plot those out, that gives us this graph. Now let's compare the expected flat Earth altitude angles to reality. At the equinoxes, the sun crosses the celestial equator, So like Sad al-Melik in our earlier look at stars, the Sun's altitude angle is simply 90 minus the observer's latitude. Let's add that to the graph. Okay, so the FLATTARDS are way off. We can see that there are only 2 latitudes that match the values for a flat Earth. There should be no discrepancy if Earth were actually flat. Once your latitude starts getting above the 50s and 60s, the error gets catastrophic. Everyone in Scotland, Norway, Sweden, Finland, most of Russia, Alaska, Greenland and Iceland should be seeing the Sun at a very different position in the sky that bears no obvious relation to their latitude. Of course, these errors apply both north and south of the equator, so when we include both hemispheres, our graph of discrepancies looks like this. FLATTARDS usually concoct ad hoc excuses involving some new kind of atmospheric distortion or some crap like that. However, even the most mentally crippled flatwit should be able to see the issue here. Earth's atmosphere is basically homogeneous, yet the discrepancy between their fantasy world and reality varies by latitude. Why do these gases care where the observer is standing? They don't. There are no properties of Earth's atmosphere that cause this. There's a direct and incredibly simple relationship between an observer's latitude and the altitude angle of the Sun. If FLATTARDS can't even get something as simple as the position of the Sun right, we can safely conclude that their sky fairy pancake is bollocks. In part 3 we'll keep our eyes on the sky and see what other problems it can cause FLATTARDS. See you then.
Sei sotto un cielo sbagliato.